All right. Okay, section 3. It's literally just this section, so not that bad at all. Okay. Okay. Now, this is called parametric equations. Okay, and I'll explain what we're going to do with this. Okay. Let's suppose you have an object lies on a circle of radius r center at the origin. We can describe the coordinates of the object. Okay. We can say that if we know the radius here, okay, which you can notice is the hypotenuse of the x and the y components. Okay, then we can describe the coordinates with the x coordinate being r cosine theta, because our cosine is right here, okay? And we can say that y is equal to the r sine theta, okay? So that's pretty straightforward, nothing too crazy there, okay? Now, here's what we're doing, right? If the object is moving along the circle such that its constant angular velocity is omega, now I need to write new expressions to account for the fact that now it has a velocity, an angular velocity. Well, hopefully, right? Hopefully we can remember, okay, that the that theta, right, just by our angular kinematic equations, theta is simply equal to omega times t. There's no acceleration. It's constant, okay? So there's no acceleration, so I don't need to account for that. And then we're going to assume that the initial theta, right? I mean, maybe we don't really need to take care of that. Maybe we're just going to assume that it starts at 0. I guess you could add in the initial theta here if you really wanted to. I'm not going to, though, just to get the point across here, okay? Then to write my parametric equation, okay, to write my equation here to get the coordinates, okay, I'm just going to replace theta with omega times time, okay, and that gives me r cosine omega times time, r sine omega times time, okay. That's all you got to do for that, okay. Now, I've got a position equation. If I want to get the velocity, all I got to do is derivative it. I have to differentiate. Okay, I have to take the derivative of it. Okay, and the derivative of r cosine omega t, that's going to give me negative r omega sine omega t. Okay, and then the other one will be, and then the y coordinate would be r omega cosine omega t. Okay. Okay. Um, and then the speed, by the way, so when it says speed, we're talking about the magnitude of the speed, right? Well, the sine part is going to help us define direction. If we just want the speed, all we got to do is consider this part out here in the front. The speed is just straight up going to be r omega, okay? And then for acceleration for a, okay, we just take the derivative again. We differentiate it again. That's going to give me negative r omega squared cosine omega t, comma, negative r omega squared sine omega times t. Okay? So I should end up with those equations for that. And then finally, to get the magnitude of the acceleration, again, it's just this term that's right in front, r omega squared. And it says magnitude, so I don't need to put the negative in there. Even though I do have the negative there, I don't need to have the negative there. Okay? Okay, that's it for section 3. Really short, okay?